Alright guys, today we're going to be talking about the proof of the quadratic formula. Um, I like this proof a lot. What it does is it shows that this quadratic formula, as you guys might know, I'll write it off to the side, and then we're going to prove what it is. We got negative b plus or minus square root of b squared minus 4ac. And that is all over 2a. And this is what x is equal to when we're solving something that on this side looks like x squared, or excuse me, ax squared plus bx plus c. That's equal to 0. So we're going to use, as you can see, I got these funny looking boxes. We're going to use a technique called completing the square. Basically, I think we'll get into this in the last bit of our factoring unit, and then we'll move on to more geometrical things. But basically, what it is these boxes can be seen as elements of an equation, and basically what we're saying is we're gonna have trouble taking a square root of something that isn't necessarily doesn't make a square shape. So what we have to do is add a square here so that we then have a square so we can take a square root. It's gonna make a little bit more sense in a second. So let's just go ahead and start working through. So let's take our formula. And since we're doing a proof, we could go ahead and write our proof up here. So this is a quadratic formula. The first thing that we're actually going to do is just divide everything by a. So I'm going to start with x squared plus bx over a plus c over a, and that is equal to 0. And then I'm just going to bring this negative c over a to the other side. So I'm going to be left with x squared plus bx over a. So here's where our completing the squared comes in. We could think about this side and break it up into different parts. So if we say that the width of this box is x by x, so this is kind of like our x squared. The width of this rectangle here and this rectangle here, the width and length respectively, because these are two they're congruent boxes, is x over 2, or excuse me, x. And there's two of them. So we have an x here. So that means x times b over a is what these boxes are. But since there's two of them, this is going to change into b over 2a. So b over 2a is going to be the width of these boxes. Let's do an orange here. It's going to be the width, and then this red we'll call the x value essentially. So now, kind of as I alluded to before, what we're going to do is we're going to make another box down here. So let's actually make up an orange box really quick. So let's get an orange box. So this is what's called completing the square. Note that the dimensions of this box are going to be b over 2a and b over 2a. So this is going to be very, very important a little bit down the line. So when we add this in, we want it to be on the left side, so we're completing the square. But we also just can't bring something into the equation. So let's take a look at this. So we're going to have x squared plus bx over a. And now we are going to have plus b over 2a. And what this is, and it's also going to be squared because we got to think about that it's a whole box. And that's equal to negative c over a. And then once again plus, oops, that's brown. So this is going to be plus b over 2a squared. So all I'm doing is I'm saying this box is now going to be in our equation. I added it to both sides, so we can mathematically do that. That's a sound mathematical thing. So what I'm going to do now is on the left side, or excuse me, on the right side, I'm going to square this out. So I'm going to have b squared over 4a squared. And on the left side, it's a little bit less intuitive, and when we get into um, actually completing the square and how this works, it's going to make a little bit more sense. But basically, what completing the square does is we can now factor this. We can unfoil it, and basically what it'll boil down to is x plus b over 2a squared. So this is what it's going to boil down to. If you have doubts about this step, just run through it and foil it, and you'll see that you'll get exactly that. But for now, you can just trust me on that. So now what I want to do is I want to combine like terms on the right side. And think about if I'm going to combine like terms, I'm going to need to have a common denominator. So I'm going to multiply this by 4a over 4a. So I'm going to get negative 4ac over 4a squared plus b squared over 4a squared. And this then just simplifies down to b squared minus 4ac all over 4a squared. So let's copy this a few times so we know what we're doing. Once we get to this step, remember we're trying to get x alone. So what we're going to do is take the square root of both sides. You can note that on the right side, we can't take the square root of what's on top very easily. But we can take the square root of what's on the bottom very easily. So we're going to get the square root of b squared minus 4ac all over square root of 2 and the square root of a, which is just going to be, or a squared, which is going to be 2a. Then since we did take that square root on the bottom, I'm going to leave that plus or minus there. Okay? Now, we're going to be left with an x plus b all over 2a. And we can combine like terms, so we're going to subtract this b over 2a to the other side. So we're going to have plus or minus radical b squared minus 4ac all over 2a. We have a common denominator now. So we are going to get exactly what the quadratic formula is. All over 2a. So this is our quadratic formula. If you have not seen it before or used it before, I know I got a few questions about it last week, but this is the quadratic formula. And basically what it would allow us to do is anytime we come across a quadratic and we don't know how to factor it, we can plug in the elements into this formula and it'll spit out our x values. So let's look at these two. If you notice with these problems, we can't factor them. There's no two factors of negative 3 that add up to negative 3. Because the only factors are going to be negative 1 and 3, and then negative 3 and 1. And those add up to positive 2 and negative 2. So what we can do is use our quadratic formula. So we start just plugging stuff in. So we're going to have negative 3. So I'm going to do this sort of exhaustively. Plus or minus the square root of negative 3 squared minus 4. A is this spot, so that's just a 1. And then C is this spot, remember. So this is just a negative 3. And this is all over 2 times A. So remember, this is going to equal x. So we have x is equal to 3 plus or minus the square root of 9. We got negative 4 and negative 3 3 times 4 is 12. And this is going to be over 2. Something there doesn't seem right. So 9. Nope, I think we're good. So we are going to be left with 3 plus or minus radical 21 over 2. And we can't simplify this radical 21 down at all. We have no perfect square factors that go into negative 21. So this is our answer there. We can look at our next one. We're going to do the same thing. So we're going to plug in x is equal to negative 8 plus or minus 8 squared minus 4 times a times c. So that's 4 times 4 times 1. And that's all over 2a. Oops, excuse me. So 2 times 8. Doing the math, we're going to have negative 8 plus or minus the square root of 64 minus 16. This is over 2 times 8. And now we'll have negative 8 plus or minus over 16. 64 minus 16 is what, 48? And what kind of perfect squares do we have in here? So we could break radical 48 into 16 times 3, which then will let us pull out a 4. So we have negative 8 plus 4 radical 3. If you don't know or remember how this works, we can maybe spend some time on it. But we could break up what's inside of a radical, and then this will just turn into radical 16 times radical 3. And then radical 16 is just 4, so that's how we get that. So this is all over 16. We simplify. What we can do is we could take a 4 out of everything. So I'm going to be left with negative 2 plus radical 3 all over 4. Oops, I forgot my minus. So plus or minus, that is what x equals. So if you go into Desmos, find the points, you're going to have something equal to this. When you're doing these types of problems, it is a-okay to leave them as is. You do not have to simplify. You don't have to find what radical 21 is or radical 3. So I want to go over real quick one item that might come up. So usually we got this form where we're just going to get negative b plus or minus the square root of something all over 2a. But what I really want to talk about is what's inside here. If when you solve here, you're going to get a negative number, just write out negative. This means that there are no real solutions. You must have this real in here because there are solutions. There are solutions to this problems. Those solutions are just going to be complex. And the complex numbers do have real value in real life applications. And it is still a solution, but there's not going to be any real solutions. So this is an okay answer to get if your inside is negative. So just be wary of that. We'll have some problems that deal with that. Yes, so this is pretty much what's going on for the quadratic formula. A little bit of the proof, the math behind it, how we get down to this point. If we don't quite understand this completing the square, that's all right. It's a little bit complex of a topic, and that's okay. Just note that is, where it comes from, this completing the square. And you will do this in your high school career. I need to talk with some of the math department of whether you're going to do it with me or whoever, or whenever you take your next math class. So anyway, I've been rambling for a bit, so have a good rest of your night. I will check this on Wednesday, so have